Yes, they have now because they are linked to the management. But maybe or there or here or something.
So they say here at last.
This one could be a good place for you.
You can get it in an app.
Okay.
Well, I might want to go out, but I want to be the microphone's going to be too close to the head for you.
And everything okay?
Thank you, dear. Thank you, dear.
Good or bad?
Eh?
Good or bad? Haven't got a place.
Perfect. How are you?
Yeah.
My best preferred photographer.
Wow. That's not what I make a mistake.
Big responsibility.
I know, it's
no,
huge.
no, no.
Huge. You haven't got a backup one.
Don't worry. And take as many pictures as you want, or the ambassador, or whatever, or whoever you want. This room is amazing. It's huge. I've never seen it. Well, when I choose it, when we choose the place. Because to be COVID compliant now, if people want to be COVID compliant, they can in this room, because we are 210 probably. If everyone is showing up, the people that sign are showing up.
So I can't see anyone wearing masks, and most people aren't.
It's not, if you want to do this,
Yeah,
if you
I have, but
you can do it.
I didn't want to.
No, you can do it. It's up to you. Absolutely. Don't feel.
You can, or then I'll take you for
Then we start doing.
Yeah, but feel free to wear the mask if you feel more
I haven't yet.
comfortable. No,
Not at all yet.
I think that here you are quite safe because you are.
Les parents
These are two my young students. Now he gets the best place to take pictures. Yeah, well that's what I'm saying. Yeah. We can share the pictures. Well, my pictures won't be right with this.
Just straight down and then
Well,
you'll have company.
I usually have people's eyes away. You have backup.
That's great.
Well, you can mix.
Right on the day.
This is Concordia station.
I'll drive over there and take a picture and then go up there.
which is celebrating Antarctica, dealing with climate change, biodiversity and science. This is an event which is hosted by the Italian Embassy here in Australia, the French Embassy and also the British High Commission, along with the AMU Climate Change Institute. But before we start, I'd just like to acknowledge the traditional owners on the lands on who we meet. That's the Ngunnawal people in Ngambri, and just pay my respects to their elders past, present and also their emerging leaders. In terms of housekeeping, just a few simple things before we start. Please put your phones on silent, not necessarily on flight mode, because you can use your phones to interact with the Q&A process that we've got, which is an online tool, which is the information which is up here. So if you put in that URL and then you can use that code, and that will take you to a site where you can put in questions and you can vote on other people's questions. So if there's a question you'd like, you can vote it, and we will, in the Q&A, we'll deal with the questions which are at the top of the list. So there's a bit of democracy that we're using here in terms of the questions. So, so you'll also have, I think we're going to run microphones from the floor as well, we don't, no, we're just doing things from Q&A off this system. But anyway, just to a very quick start to paint the background, of course. Now, Antarctica is one of the most, or is the most untouched continent on the globe. It's also an amazing place which has many countries engaged with, and Australia being amongst them. It's incredibly remote, difficult to get to, difficult to get back from, but we've got good connections here, hopefully this evening, to speak with people who are down there. It's also one of the most rapidly warming places on the Earth, and so impacts of climate change are already showing up in various ways. It's showing up in terms of changes in biodiversity, biological responses. It's showing up in terms of the melting of the West Antarctic Peninsula. But worryingly, it's starting to show up in the melting of the East Antarctic ice sheet, which we thought was going to be robust and stable under climate change for a long time to come, but it's already starting to break down. So it's a real concern. So we'll be talking today with people who are about dealing with the next phase of the EPICA project. So the EPICA project that was run some years ago put the longest borehole down into the ice ever, and it recorded essentially an 800,000 year history of the Earth. Each of the little bubbles in the ice has carbon dioxide and other gases trapped and can be sliced and extracted, and it gives a feel for what was, or a measurement of what was happening in that particular time of the Earth's history. And this is an incredible record which they're anticipating to extend with a new project. And that's currently funded by the Science Council of Italy. So they're aiming for 1.5 million years, which will go over a whole range of new ice ages beyond what the previous sample could do. So we're also going to be discussing here this evening the impacts of climate change on biodiversity and what science can tell us about what's going on and what might happen in the future. And so we've got some great speakers here this evening to cover that. So just to give an introductory address, I'd like to invite up to the stage Her Excellency Francesca Tardioli, and Francesca's been a mainstay of the Italian diplomatic service for 30 years. Welcome, Francesca.
Thank you very much, Mark. Distinguished guests, ladies and gentlemen, good afternoon and good morning for those who are connected via remotely. I think that one of the indications about the importance of this event and the theme these events will discuss is the huge number of participation. So thank you very much to all of you and to those who are connected remotely. Antarctica Day was established almost 10 years ago to celebrate the Antarctic Treaty, signed on December the 1st, 1959. And this treaty is a unique example of the world's international governance of a very special region. It affirms that Antarctica continent is a natural reserve devoted to peace and science. It encourages scientific cooperation through exchanges of researchers and free sharing of the scientific results. Supporting the Antarctic Treaty System is the Commission for Conservation of Antarctic Marine Living Resources and the Protocol of Madrid for Environmental Protection. Since 1959, 54 countries have acceded to the treaty, of which 25 are non-consultative partners, so with no vote right, but they do participate to the activity of the bodies themselves. Italy signed the treaty in 1981, and since then, through the Programma Nazionale di Ricerca in Antartide, Antarctic National Research Program, has been conducting extensive research in many fields, including oceanography, glaciology, biology, physics, astrophysics, life and earth sciences. Italy has 2 research stations down there. Mario Zucchelli Station, located on the coast of the Ross Sea area and is operated only in summer, when it can be reached both by airplane and with our icebreaker Laura Bassi. The second one, at Dome Concordia, jointly operated by France, is located on the Antarctic Plateau at 3,233 meters above the sea level. It is 1,000 kilometers inland from the Italian Zucchelli Station at Terranova Bay, 1,100 kilometers inland from the French research station at Dumont-d'Urville, 1,100 kilometers inland from the Australian Casey Station. And it's a permanent station, operated both in winter and summer. Dome Sea is the place where the ice drill project EPICA, you've heard it already. EPICA stands for European Project for Ice Coring in Antarctica, was carried out and provided the longest chronology of greenhouse gas concentrations up to 800,000 years ago. Results provided by EPICA made clear that the present day levels and rates of greenhouse gases increase are unprecedented over the last 800,000 years, and humans are responsible for these dramatic changes. Antarctica Day provides an opportunity to reflect on our collective responsibilities in combating climate change and in preserving the ecosystem for the future of our planet and for the future of our children and the next generations. Current national commitments on greenhouse gases reduction undertaking following the Paris Agreement are not sufficient to keep global warming below the warming threshold of 2 degrees Celsius, which is considered not an ideal, but at least an adequate target. In 2021, next year, United Kingdom, in partnership with Italy, will host the 26th Conference of the Parties to the United Nations Framework Convention of Climate Change, better known as COP26. Italy will host preparatory events with a strong will to contribute to a general increase in ambition as well as participation and inclusion of different segments of the society, in particular young people. I wish to thank the director of the Climate Change Institute for organizing this event, and obviously my colleagues of the French Embassy and of the British High Commission here in Canberra for being our partners in this. And I wish to thank all researchers and staff from any nationality that are now in Antarctica to provide the science we need to better understand the evolution and the future of our planet. Thank you.
Thank you very much, Ambassador. It's a great introduction. So our first speaker is Dr. Rocco Ascioni. Rocco has a PhD from Milan University in Mechanical Engineering, and since 2017 he's been the station leader down at the station that the ambassador talked about, the Italian-French Concordia station, which is located near Dome C, where this core is going to be driven down into the ice. Hopefully we've got Rocco online.
No. Hello everyone, can you hear us?
Yes, we can. You're online.
Okay. Do you have an estimation or... Ciao! Ciao Carlo, come stai?
Benone voi?
Bene, bene.
Va bene Carla, ciao.
Forte.
Quella foto mi ricorda qualcosa.
Ah, hai visto? L'ho messa apposta.
Okay, please start. You're online. We can hear you and see you.
Sì, sì.
How do we communicate? Can you see the chat, Julia?
Noi siamo pronti, we're ready. We're ready to start. We have all the guys ready to talk, so whenever you want, we are ready to talk.
Yep, we're ready.
Can you see me now?
We're
See?
plenty ready.
We can see you, Carlo.
Nice.
Okay, they're not picking us up, Juliet, I don't think. Nothing's popped up on the chat.
We can start for the interview, or we have to wait to someone that introduces us.
You're right to go.
I don't think they have their speakers on.
But they've got their image, they should be able to see. So, which this? Yeah. Rocco, can you hear me?
Yes, now we can hear you.
Okay, we're ready to go. You can start now.
Okay, thanks. Welcome everybody from Concordia Station, Antarctica, the Italian and French station. And we are here to talk briefly about the life in this station and how is doing science in these places. I'm the station leader and I'm here for the summer campaign, but also with me I have our colleagues, the French and Italian colleagues, but not only, because we have also persons from other countries. And I ask them now, I quickly introduce them, and I ask them now to bring their experience to you, because they are the main person, the important person to speak about their experience, because they did the winter over here in Concordia during this past winter. On my side I have Loredana, the medical doctor of the winter over. And I have also here Alberto Salvati, the physics of the atmosphere and the former station leader. We have also Stein Tulen, the doctor from ESA, and we have also the two French glaciologists, Ines and Camille. So I will ask firstly to bring you both experience from the Italians and French from the winter campaign. So I pass the microphone to Loredana.
Hi everybody, I'm Loredana Faraldi and I'm the medical doctor of the station.
Hi everyone, I'm Stijn Tola. I'm the ESA research doctor here on the station for the past year. Right, European Space Agency, excuse me.
Hi everybody, I'm Ines Olivier and I was the glaciologist for the winter rover this past year. Glaciologist for the French side, for French laboratory.
Hi everybody, I'm Camille Briand. I'm the other glaciologist here, chemist and glaciology, and I'm French, but I was working for the Italian part.
Now, Loredana will start with the description of her experience during the winter campaign.
The winter is very special here in Concordia because you have a unique experience that you can live in your life, because you have these 3-4 months in the middle of the winter of completely dark. But even if you have this completely dark, it's very amazing. It's fantastic because you can appreciate much more the positive side of this living in this environment, because the sky is very, very special, and because it's so special, you can do some studies, some research, all here in Concordia or all in a few other stations in Antarctica. And it's also a special experience because from a human point of view, because you can live with a few people. In this case, we were 12 in total, 12 people from different countries. So from Italy, French, and Holland in the case of Stein. And so it's a particular strange situation. For example, you create a strange language when you talk Italian, French, Dutch, also Deutsch, because sometimes we invent words and it's a mix of languages. And the life is strange also because you are in this environment and you cannot do everything you want to do, like when you are at your home. And so you have also to develop some mechanism to cope with some stressor, we can say, elements, like the life altogether in a so close, in so small location. And sometimes it's not easy, but we are all quite young, at least I can say quite young for me, but we have many young guys. You can see Ines, Stein, Camille, and no, Alberto no. But I think it's also a good balance also for the age. So sometimes you need to find a manner to cope with these stressors, but it's a very important experience in your life that I think every one of us will remember for the rest of her life. And for sure is a unique experience. I pass the microphone to one of the glaciologists, to Ines, to have her point of view.
Yes, so Camille and I were the two glaciologists on the station for the whole winter, and we were going outside every day, or every other day, but quite often. And it was a beautiful scientific experience here, and also from my point of view, I learned a lot how to handle stuff in the field in a tough environment, such as Concordia in the winter. It was a hard job to collect samples outside during the whole year, especially when it was night and very cold. But it was also very challenging, and I learned a lot. So it was a very, very cool experience to live here and to make the scientific programs advance during the year.
Okay, so for the scientific programs, we are doing a lot of things with Ines, but not exactly the same. Most part of our job is to work on the aerosol. So for me, it's this. So it means that I took all the impurities, everything that we can have in the air, in the atmosphere, and after it will be analyzed in Italy or in France. We collect also a lot of snow samples. Not ice. During the winter it's impossible to collect ice because we don't use a driller. So we collect a lot of snow to have physics or chemistry properties. And I think more or less this. We collect a lot of snow.
I will try to add something from my experience. So you can think of Concordia a little bit as a sort of future planetary base. It's an extreme environment, it's far from home, we're isolated, confined, a lot of stresses, Loredana already mentioned that. And European Space Agency is interested in this as it helps us to understand how people deal in such a place. So I'm here to implement biomedical research programs for the European Space Agency. And that means that I'm not working with snow or with the atmosphere, but I'm working with the people here, which I think has been kind of exciting over the past year. So we did all kinds of different projects on how we adapt to this place, and that was scientifically a lot of fun and exciting because I can work with the people. But I think for me, the Winter Rover personally has also been exciting. First of all, for what you see outside and living in such a strange place that is so different from home. I guess it gives me, at least that's what I'm curious about when I come back home, is I guess it gives me a bit of perspective. It's something completely new that I think we will learn from, but what I like most is maybe to see how me, but also as a group, how we deal with together with being in such a strange place. And it's kind of interesting to see how people act differently in different times and with different challenges. And for me, this was super exciting and interesting to see.
Okay, thank you to our colleagues. We finished for the first round of our experience. So, but of course, we can stay here for hours to talk about this on this topic because it's very open, it's so wide. So, but we are fully available to stay with you and in case to answer to direct questions, or also the colleagues here are fully available. So if during this talk there will come also questions or curiosities to answer, we are here for you.
Now we've just got a short video which hopefully will show the surrounds of the Concordia station.
Over the last 3 million years, the Earth's climate has oscillated between cold and warm periods. However, due to human activity, temperatures are very likely to soon reach unprecedented levels. In order to understand what is happening at the moment and to prepare for what the future holds, we need to understand more about the factors which cause climate oscillation. Antarctica is a remarkable continent. It's remote, hostile, and uninhabited, and it holds the key to understanding how our climate system works. The Antarctic ice sheet contains a unique record of the Earth's climate history, thanks to its ice which has accumulated in layers from old to new over hundreds of thousands of years. In addition, the air bubbles embedded in the ice preserve a record of the Earth's atmosphere through time. 20 years ago, the European project for ice coring in Antarctica, EPICA, obtained a deep ice core which covered the last 800,000 years of Earth's climate history. The ice core revealed that concentrations of greenhouse gases over this time period had never been as high as they are today. The new Beyond EPICA ice core project aims to go beyond that. A team of scientists from 10 countries, funded by the European Commission, have set up camp at Little Dome Sea in East Antarctica. They aim to drill a new ice core, reaching back at least 1.5 million years. This time period includes a major transition in the rhythm and intensity of the Ice Age cycles. What drove this change is still a mystery. Unravelling the links between the carbon cycle, the ice sheets, the atmosphere, and the ocean during this major climate transition is therefore the goal of Beyond EPICA, and is vital to understanding the processes governing our climate system. This, in the end, will help us to design effective mitigation and adaptation strategies to the current man-made climate change, and improve our ability to predict future climate changes.
Thank you for that. So our next speaker is Professor Carlo Brabanti. Carlo is the leader of the Institute of Polar Sciences with the National Research Institute in Italy. He's also a professor at the University of Venice. Welcome, Carlo.
Good afternoon. Thanks to the kind introduction. If you don't mind, I would simply share a short presentation that I prepared about the project you have just seen a minute ago. So the project is named Beyond EPICA, and is a great effort that the European Commission is putting up to retrieve an ice core of 1.5 million years, because under the feet of Rocco, Alberto and the crew in Concordia there are more than 3 kilometers of ice, which for us is an incredible archive of the past climate and the past environmental condition that we had. So the snow accumulates year by year, layer by layer, and so we can go in the field and retrieve this long ice core onto the battle, where we know that there are several information. And snow is transforming very, very slowly from snow into dense snow and then into ice, trapping also inside very small bubble that retain the atmospheric composition of past. So we are good enough to date this ice, and we can go back so far, exactly underneath Concordia Station with a project that was called the European Project for Ice Coring in Antarctica, about 800,000 years of the Earth climate history. This was a great challenge, one of the most iconic projects of the European Commission, and certainly one of the most cited when you speak about greenhouse emission and so on. Because out of this ice, we were able to obtain a lot of information, especially looking at the concentration of the air trapped into this tiny bubble, which are stored into the ice. And as you see, I mean, over the past 800,000 years, we were able to follow the temperature of the past and the greenhouse gases concentration. So you see that temperature and greenhouse gases oscillated from low to high according to Planck cycles, so the orbital parameters that have been running for millions of years. And what is really remarkable, what happened in the last few decades, where we know that the greenhouse gases concentration ramp up to more than 415 parts per million. We never had, and I underline, we never had such a high greenhouse gas concentration over the last 800,000 years. And this is something which is remarkable because we know that the CO2 concentration and the temperature are tightly linked. We know that greenhouse gases are the most important players in the global warming. So the reason to continue on this field of research brought us to a new adventure, which, as you have seen in the short video, is called Beyond EPICA. We want to go beyond that period of time, trying to find ice as old as 1.5 billion years. To look at ice of that age is not just simple to beat a record, which is per se already something good, but if we go far back in time, more than 1 million years, we are jumping into an unknown period of time, which is called the mid-Pleistocene transition. It's a period of time in which the climate changed completely its way to operate from, of course, a natural point of view. So unless we do understand this period of time, the so-called mid-Pleistocene transition, we can't really well understand what is happening today. So it's a paramount important to have a continuous record that extends down into this unknown place. And we are seeking for ice, 1.5 million year old ice, and we know where it is. We spent the last 3 years in Antarctica to search for this ice, and incidentally, this is very close to Concordia Station, in a place which we call, we don't have too many fantasies, scientists are like that, we call Little Don Sea, which is just next door to Concordia, 40k away, where we know that there is ice as old as 1.5 million years. We run more than 20,000 kilometers of radar line, looking at the surface, looking at the layering, looking at the background of the rock underneath the ice. And so underneath about 2.7 kilometers, we found a place pretty flat, which is on the top of this small highland that you see on the right, which is this one that you see, where we modeled and we know that there will be ice as old as 1.5 million years. And all this small island, which is about 5 kilometers long, is surrounded by completely by water. And so last year, the team of the European team selected a place finally where we are planning to do the drilling. And it's funny to say that this guy hanging the European flag is a UK colleague from British Antarctic Survey. They are leaving Europe and they are standing within this fantastic project. So we set up a camp there, which is, you have seen already in the short video, is almost there, and I would recommend Rocco to have a barbecue party as soon as possible to see if everything is there, because we are very much interested to go there. So this is also very important because it's part of a great Italian-French cooperation, and I'm sitting here together with my friend and colleague Jérôme Chatelat, who is the director of the Institut Pôle Victoire, which together with ENEA are running the Concordia station, and they are fundamental in running the Beyond EPICA project in the year to come. There is a lot of logistics behind that. Imagine to transport 22 tons of air cargo, 100 cubic meter of fuel, 80 tons with traverse, with a caravan like that. There is one arriving in the next few days in Concordia with a lot of material for our building. We have a budget which is about 30 million, and we are planning to spend 5,000 man days in the field. It's a long story in front of us. This red line is this year, unfortunately, is what we call a COVID year. No man in the field, but as I said, we will do, and we are doing some experiment in Concordia, trying to set up the conservation of the ice. This is the timeline that we have. We plan to go again next year, 21-22, for starting the drilling in the field, and we literally hope to be successful in the years to come, and in 24-25 we should see the first results coming out of there. The camp is set up, as I said, and we are all waiting you if you want to visit us in Concordia in the year to come. It's a very challenging project. Is a part of a great international cooperation, including Australia. We are in a very good relationship with the Australian Antarctic Division. That they are planning to set up a camp 5 kilometers away from us, also to drill a deep ice core. And this is an important logistic endeavor that see together Italy and France working elbow to elbow on this fantastic adventure. Thank you very much for your attention.
Thank you, Carlo. So our next speaker is Professor Neroli Abram. So Neroli is at the Research School of Earth Sciences. She's a rising star in her discipline, and she does amazing work using many different types of data and many different types of analysis to find out what's happened in the past and what's happening now, and then communicating it with people. Neroli was a convening lead author on the recent IPCC special report on oceans and cryosphere, and we're very lucky to have her here today. Thank you, Neroli.
Thank you, everybody. I'm really pleased to be here to share this celebration of Antarctica with you. What I'm going to do today is to talk a bit about some of the changes that we're seeing in Antarctica, particularly drawing on some of the impacts that we've seen in the past year and some of the new discoveries that are coming out in the literature. So, for most of the last century, we would have said that Antarctica was looking fairly quiet in terms of changing temperatures. You can see on this map temperature trends from 1958 through to 2000. Most of the world is warming, but if you have a look right down the bottom of the map, apart from the Antarctic Peninsula, there's not much going on over Antarctica. We start these trends in 1958 because the International Geophysical Year marks the start of good observational records over Antarctica. If we now fast forward and we show those temperature changes now through to 2019, we can start to see that Antarctica is now showing a strong climate change response. So we see the magnitude of warming increasing all over the world, but Antarctica is no longer looking so quiet. Now, understandably, as we start to warm the climate, we expect that in some places we're going to start to see ice melting. So particularly around coastal Antarctica, as the temperature rises, we see melting of the surface of the snow and the ice. This is an image captured by NASA in January of 2020, showing melt over one of the ice shelves along the Antarctic Peninsula. And this type of melting is a process that can cause those ice shelves to rapidly lose their structure and to disintegrate. At the start of 2020, we also saw records tumbling in Antarctica. This image here talks about a record that was broken on the 6th of February at Esperanza Station, I think, or Marambio. And then 3 days later, the record was broken again, and that was the first time that a temperature over 20 degrees in the summer has been recorded in Antarctica. So those record-breaking temperatures are part of a long-term warming trend, but that's not all that was going on in Antarctica last summer. So we also saw a very rare event, a sudden stratospheric warming event, which developed high in the stratosphere, and by the summertime, those climate anomalies had propagated down to the surface and were affecting the climate around the world. So that was one of the reasons why we saw those record-breaking temperatures in Antarctica last summer. It was also one of the factors that led to Australia's Black Summer, where we had that climate set up over Antarctica that also has an effect of causing parts of Australia, particularly the eastern parts of Australia, to become hotter and drier, increasing our fire risk. Another way that Antarctica impacts us in Australia is through sea level rise. This is an image from July of this year showing coastal erosion at Wamberal Beach in the Central Coast. This is the type of high sea level event that we expect to become more common with global sea level rise. In the recent IPCC assessment report on the ocean and cryosphere, it was estimated that high sea level events that used to occur along the coast of East Australia once every 100 years would become a once every year event by the middle of this century. So this animation, it's playing, this animation shows ice loss from Antarctica measured by the GRACE satellite. What we can see is a clear loss of ice, particularly focused over West Antarctica, but we also see some signs of ice loss beginning to develop in parts of coastal East Antarctica as well. So you can see that area that's now becoming very dark red. This is the area of West Antarctica where we're particularly losing a lot of ice from Antarctica. And the reason that this is an area where we're losing a lot of ice is because it's in a particularly unstable setup. The ice sheet here is in contact with the ocean, and that means that warm ocean water is able to very easily erode the ice sheet from beneath. And the ice sheet is also sitting on land that slopes deeper as you go further inland. So what that means is that as we start to lose the ice sheet, we then start to expose more of the base of the ice sheet to a warm ocean. So this sets up a very unstable situation, which we refer to as a marine ice sheet instability. So the West Antarctic ice sheet, because of that configuration, it's been long known that it was an area that we should be concerned about. But 30 years ago, when we were at the first assessment report of the Intergovernmental Panel on Climate Change, this concern was noted, but it was expected that we wouldn't actually see much change at all from Antarctica in the coming century. If we now fast forward to last year and the special report on the ocean and cryosphere, what we can see now is that we have the data to be able to see that Antarctica is contributing to sea level rise. It's contributing at an increasing rate to sea level rise. And there are concerns now that the West Antarctic ice sheet may be approaching or have even passed an irreversible tipping point. So this is another animation modelling what happens to the Antarctic ice sheet as climate begins to warm, so at different temperatures. Those purple spikes that you can see, those are tipping points that are produced in the model. So we can see one tipping point at about 2 degrees Celsius, and that's the tipping point where the West Antarctic ice sheet becomes irreversibly lost. So if we get to warming of 2 degrees, this work would suggest that the West Antarctic ice sheet will be lost, and it can't be recovered even by stabilising temperature back to 2 degrees. The other tipping point that you see at about 7.5 degrees relates to the East Antarctic ice sheet. So the East Antarctic ice sheet is sat mostly on ground that is above sea level, and so this tipping point relates to the point where the top of the ice sheet has become so low and the atmospheric temperature has become so warm that the ice sheet is being melted from the surface instead. So particularly that 2 degree tipping point is a real sign as to one of the reasons why we have those targets in the Paris Agreement and why it's important that we don't exceed them. So the sea ice around Antarctica is another area of concern. If we look at the observational record of sea ice change, we can see that over most of the record there has been a gradual increase in the amount of sea ice around Antarctica. And that was something that we believe is to do with changes in the winds around Antarctica and also fresh water coming into the ocean promoting the growth of sea ice. But we can see that a maximum was reached in 2014, and then there was this very precipitous drop in sea ice from 2015 to 2018. And to put that in context, the loss of sea ice in the Arctic is something that's talked about quite often, and we can put that on here on the same scale. And what you can see is that the very dramatic loss of sea ice across the Arctic, the amount of ice that the Arctic has lost over 30 years is equivalent to the amount of sea ice that Antarctica lost in just 3 years in the past few years. So sea ice is an important part of the climate system. It's also really important for ecosystems. And so any changes that we have in sea ice around Antarctica will have implications for the marine life around Antarctica as well. But changes in sea ice won't be the only implications. A warming ocean and an acidifying ocean will also present challenges to marine life around Antarctica. Now, when we think of Antarctica, we often have images of a wilderness, and in many places that is true. And a study that was published earlier this year actually tried to quantify where is Antarctica's wilderness, and it did this by assembling the historical records of all human activity on the Antarctic continent over the last 200 years. So the areas in here in purple are the places that you would say are truly untouched by humans. So those purple areas largely are areas that look like this. Fantastic if you're an ice core scientist, but not so good in terms of the richness of biodiversity that this type of ecosystem would support, or this type of environment would support. So what we find is that most of Antarctica's biodiversity is concentrated on the rocky outcrops and around the coasts. And those are also the areas that have the most intensity of human activity. And so we do have a coming together there of the needs of protecting Antarctic wilderness with the type of places where we're putting pressure on the continent as well. And so just to wrap up, I just wanted to point to two special research initiatives or strategic research initiatives that have recently been funded in Australia. And these are going to be going towards tackling a couple of those problems that I mentioned in this very quick overview today. So firstly, the Antarctic Centre, the Australian Centre for Excellence in Antarctic Science is a project led out of the University of Tasmania, including the Australian National University. And that project will be looking at trying to understand which parts of the East Antarctic ice sheet might be particularly vulnerable to change in the future. So those type of changes that we're seeing in West Antarctica, where in East Antarctica do we also need to be concerned about? And the Securing Antarctica's Environmental Future program is being led out of Monash, and that will be developing a robust way of assessing the risk of ecosystems in the future and how best to protect those. Thank you very much.
Thanks, Nera. Our last sort of guest and speaker is Dr. Emily Chakra from Cambridge University. So Emily's the director of the Cambridge Zero program at Cambridge, which aims to reduce emissions to zero. She's got a scientific pedigree as long as my arm, so I won't go through all of that, but a couple of things that jumped out at me from her CV. One of them is that she's a fellow of the Royal Meteorological Society, so she's a fully accredited person to talk about climate. She's got an OBE for Services to Science, and she's a co-author with His Royal Highness the Prince of Wales and Tony Juniper on the Lady Bird book on climate change. Welcome, Emily.
Welcome. Hello.
So Emily, what we're just going to do is ask a couple of questions for you to reflect a little bit and expand on what you've heard. So we've heard so far in this event some really amazing science that's being done by our European Union colleagues. And the question I've got is, how do we best get this into policy so as to make a difference for Antarctica's future?
Yes. So I think that actually in the presentation from Carlo and Neroli, you heard some of the most important, the most impactful aspects of Antarctic science in terms of policy. So the first thing that you heard from Carlo was about the ice core record. And Carlo himself said that this is an iconic piece of research that's one of the most cited. And it's one of the most cited because it helps address the question of how unusual the current climate change is in a much longer term context. And for that reason, it is incredibly important for helping shape policy because it helps inform the scale of the current climate change. The second thing that you heard from Neroli was how changes that are occurring in Antarctica affect us throughout the world, particularly through changes to the ice sheets, for example, leading then to sea level rise around the world. And again, that's another key piece of research that helps inform policy because it helps us understand the scale of the changes that could be ahead of us. And the third thing that you heard from Neroli was about the very unique wildlife both on Antarctica and also in the oceans around Antarctica. So much of that wildlife is incredibly well adapted to the extremely low temperatures, but therefore also incredibly susceptible to change. And so, I would say that that's the third key aspect of research that helps us, understand how we need to protect these really unique species and how we should shape policy in order to do that. So Antarctic science, probably more than any science elsewhere in the world, is just so uniquely placed to help shape that policy dimension. And that's policy both through, of course, the Antarctic Treaty System, but also much wider policy. You've already heard how instrumental much of the research is in terms of the IPCC, the Intergovernmental Panel on Climate Change, and therefore then also feeding into the international climate change negotiations.
Thanks for that comprehensive answer, Emily. Now, just for the second question, just thinking forward, what is, in your view, is the next research portfolio that we need that will actually help protect the region?
Yeah, so that's you've heard, it's sort of having a crystal ball, if you like, in order to be able to answer that question is quite challenging. But I think that there are some of the things that we've already heard about where there are still really significant unanswered questions. And perhaps one of them is around this question of tipping points, which Neroli mentioned. Really understanding that there's some evidence, as she described, that the West Antarctic ice sheet, aspects of it could already be in an irreversible retreat or close to. Really understanding the details of that is obviously of absolute critical importance for global society, and not just understanding it. That understanding it involves measurements, but it also involves linking that through to modelling. There are quite a number of research programmes, including I used to work at the British Antarctic Survey together with and other colleagues in the UK, together with colleagues in the United States, have been undertaking a very large research programme in the Thwaites Glacier over recent years to look at that. But there's so much more that needs to be understood around Antarctica in terms of those changes. So, that's one aspect. We've heard from Carlo about the amazing Beyond EPICA project, which is extending that ice core record back into a zone in which there's still significant need to understand and exactly understanding the details of, as he was describing, how changes in the Earth's orbit have affected carbon dioxide levels, and then temperature in the past is also critically important. And then the third area that I'd highlight, which is the area that I used to study frequently, we've been talking about Antarctica itself, but of course there's a very large ocean surrounding Antarctica, which is also incredibly important. It's incredibly important because that's the way in which the rest of the global system connects with the ice sheets. And much of the melting of the ice sheets is occurring because of the warmer ocean waters coming underneath the ice sheets. But it's also critically important because it's a very large sink of carbon dioxide. There's a very large amount of carbon dioxide that's soaked up into the Southern Ocean. So properly understanding the processes associated with that and how they may change in the future is another area of significant research interest.
Thanks, Emily. We'll just move on to the next part of the program, but I think you're staying online for questions from the audience. But thank you for your answers there. Just before we go into Q&A, we've actually got a small award ceremony. We have here Julie Lesauce, who is the Deputy Head of Mission here at the French Embassy in Canberra, and she's giving some awards to the students from Tilapia Park who are sitting down in the front.
Ladies and gentlemen, mesdames et messieurs, distinguished guests, distinguished scientists on the other side of the world. It is a pleasure to be here tonight to present this third Astrolab competition prize to the two winning teams from Tilapia Park School. The prize was established 3 years ago by the Embassy of France to raise awareness in young people about the uniqueness of the Antarctic environment and how it is impacted by climate change. Students from Tilapia Park School are asked to team up to tackle scientific topics related to Antarctica, and their project involves a scientific experiment which they have to design and conduct in their home. The prize is named after the Astrolab, the French vessel that carries scientists to Antarctica every year, leaving from Hobart, Tasmania. The level of the competition was very high this year, and two teams emerged as clear winners. I'm going to give their names. So the first team was composed by Pooja Vijay Kumar, Nadel Chua, Marcellus Lieu, and Dinara Gunasekera, who won for their project entitled How Does the Temperature of Water Affect the Ocean's Ability to Absorb CO2 and its ability to mitigate the effects of climate change. The other team was composed by Rémi Barberet, Thomas Deporteur, Tavi Williams, and Max Swan, and they won for their project entitled What Are the Effects of Temperature on the Energy Value, Calories, of Plants? So please, join me in congratulating our young scientists. Big bravo, and congratulations to you. Thank you so much.
Thank you, Julie. So the big reward that your students get for getting those prizes is you can actually ask a couple of questions of the panel, which includes Neroli. And so have you got any questions that you want answered?
Good evening. I'm Nadel Chua, Year 9 student at Tilapia Park School. I did have a question today. It was, given the current rate of global warming and the melting of the ice in Antarctica, would ice cores remain the best method to test the CO2 levels in the future?
Okay. Yeah. So for our audience, so the guests on the video, is the question was, given what's going on, are ice cores the best way of finding out the changes in temperature? Anyone want to pick that up?
Carlo's probably the best person to answer this, but I'm very happy to answer it as well. The temperatures in Antarctica are so cold that actually, although we are concerned about the melting, as I described, the ice sheets are predominantly melting as a result of that warmer ocean water coming underneath. But in terms of where Carlo has been drilling his ice cores, I'm sure he'll tell us that there's probably not that much melting going on in that region. Is that right, Carlo?
Yeah, you're fully right. Average temperature in Concordia is about minus 52 degrees. That means as an average temperature. I don't know how it is the weather outside Rocco and Alberto. It should be pretty chilly today. So for I would say the year to come, we will have no problem to find a good record of temperature and CO2 inside the ice. But I would say that we are facing this problem in the alpine region or in non-polar ice core, where we know that the signal is going to be missed because of the melting of the ice. So that's a very, very big problem for the reconstruction of the past climate in a temperate region, and also in some of the Arctic field, in the Arctic field where we do retrieve the ice cores.
Thanks, Carlo. Any additional points, Narrowly? No? All good? Have you got another question?
Yeah. Hello, I'm Remy. I just wanted to know, are the drilling of these cores solely restricted to regions in Antarctica, or would it be possible to drill them, for example, in the Arctic regions?
Okay, did you hear that? So the question was, is...
Didn't pick up question.
Do you want me to answer again? Because I did hear. So absolutely, the ice cores are drilled elsewhere in the world. They're drilled, there's a very important ice core record from Greenland. It's not as long as the Antarctic ice core record. It's really only in Antarctica that you can hope to get back that 1.5 million years. But there are other important changes that we are able to determine from the Greenland ice core record. And one of those important changes is looking at periods in the past when there's been really abrupt climate change. So we know from that Greenland ice core record, for example, that at least within the North Atlantic region, there have been periods in the past when the temperatures have changed by perhaps almost up to 10 degrees Celsius in as little as a decade. And understanding those really abrupt changes is really critical, another really critical question in terms of our future climate, because we want to understand whether or not those sort of abrupt changes could happen again in the future.
Carlo, have you got anything to add?
Yeah, I'm back again, but I didn't pick up the initial question, and the connection was completely lost. Sorry.
The question, Carlo, was just, are there other places than Antarctica that you can do these sorts of ice cores?
Oh yeah, Greenland is a fantastic place, although it is threatened by the warming, and especially the surface warming. But anyway, we have a fantastic climate record from Greenland, going back in time about 125,000 years ago, which give us several information, especially about other climate changes that happened during the last 50,000 years. We are living very, very special period of time. The last 10,000 years have been incredibly stable. So if you compare the last 10,000 years with the previous 30,000 years, I mean, we are very lucky to live in a period of time like this. Our interglacial, our warm period is incredibly stable.
Thanks, Carlo. Any further questions from the students? In which case we'll... Okay. In which case we'll open it up to the audience. So the first question we've got on the question system is, the Antarctic Treaty was created during the geopolitical tension of the Cold War. What lessons can we learn from the history of the treaty for global cooperation on science, climate and environmental protection in 2020?
Yeah, so I think Antarctica is just a great example of what you can achieve when you have that type of international cooperation. You look at the type of project that Carlo described, and that's the type of project that no one country can do by themselves. It takes a number of countries coming together to really talk about what are the important scientific problems that we need to tackle to better set the world up for the future. And then brings those countries together to actually work together to have the logistics to actually get to Antarctica and to do the work, to then do all the analysis that needs to be done. And then bringing that also together into sort of international reports, so the messages that we're getting from science in Antarctica make their way into policy decisions as well. So I think that the type of work that we do in Antarctica really sort of demonstrates why we need that international cooperation, and I think that the Antarctic Treaty is a really important sort of example of what can be achieved if we do work together as a world in cooperation.
So is there anyone on the screen?
Yeah, if I might add something, we have to remind that in the middle of the Cold War, French and Russian were cooperating in Vostok Station, and also other Western countries were cooperating on that. I think Antarctic Treaty and Antarctic research, and I would say science in general, is a great example of cooperation in between civilization and the countries that work together with a common target. And I think we have to learn a lot from this and from science.
Anyone else want to comment? No. Okay, we'll move on to the next question, and I'll wrap two questions up here. So when you're looking at drilling a core down 1.5 million years, how long is that core in meters? And how, when you're sampling this, how do you stop the ice from melting when you're trying to capture the little air bubbles?
Good question. The place we selected nearby Concordia, 2.7 kilometer deep, so 2,700 meter deep. We take it out in pieces of meters that we cut down in 1 meter sections. We put them in isolated box, and we plan to transport at -50, because there are some of the things we want to analyze, especially gases that might diffuse from the ice into the atmosphere. So we want to keep them inside the ice. And that's a big challenge. We are still thinking how to move the ice from Concordia station to Europe. It's a long journey. We were thinking about very fast transport with air freight from Concordia to Terranova Bay, Mario Zucchelli station, and then New Zealand, and then directly to Europe. But most likely we will put the ice into -50 containers in Mario Zucchelli station, and then we move them with the ship to New Zealand or Australia, and then to Europe. It is a long journey. We have to cross the equator, very hot temperature. We plan to have a double 2 containers to be safer on that, but is a worrying thing. Yeah, certainly it's not easy.
Yeah, so just to add to that, so Carlo mentioned that the ice cores that they're going to be drilling at Little Dome Sea are around about 2.7 kilometres deep. Just to put that into perspective, we saw that other core that had been drilled at EPICA Dome C, which has the 800,000-year record, was actually longer. It was 3.2 kilometres deep. And the longest record that has been drilled in Antarctica, I think, was 3.6 kilometres deep. That was at Vostok. But it only goes back 400,000 years, because at that point the ice sheet becomes so thick that there's actually liquid water at the bottom of it. There's a lake underneath where they drilled the Vostok ice core. So choosing the site to try and find this 1.5 million year old ice has been a real sort of trade-off between finding ice that's thick enough but not too thick that we're going to have lost the record from melting at the bottom of the ice sheet.
So the next question is there a one-to-one correlation between data from Greenland and Antarctic, and if they vary, why do they vary?
Yeah, I can start with that one. So there isn't a one-to-one connection between Greenland and Antarctica, but there is a very close climate connection. So one of the things that we see, particularly when Emily was talking about some of those very rapid changes that we saw in Greenland climate in the last glacial period, where temperature over Greenland might have increased by 10 degrees or more in a decade. What we see in Greenland is these very abrupt jumps from a cold state to a warmer state, whereas in Antarctica we see a gradual warming and a gradual cooling over that time. And what that's reflecting is the way that the Earth is moving heat between the hemispheres through the oceans. So there is a climate connection there, but it's not one where as one place gets warm, so does the other pole.
And maybe I can add something in there, because as Neroli said, the connection between the Antarctic and the Arctic is, one of the key things that connects them is, of course, we have a global ocean that lies between them, and the ocean has a vast, very slow overturning circulation, so that actually water that sinks down, or in today's climate, water that sinks down, somewhere north of Scotland, finds its way all the way down the Atlantic and then comes up to the surface around Antarctica. Changes in that circulation can result in changes in the way in which Antarctica and the Arctic are connected together. And it's, we were talking about what some of the key research questions are. One of the key research questions is exactly understanding how that circulation has changed in the past, and how therefore the connection between Antarctica and the Arctic has changed in the past.
Thanks, Emily. And to put that into the popular context, that was the, what was the name of the movie? The Day After Tomorrow scenario, where the Atlantic overturning circulation collapsed and everything just went chaotic. It's not true the way it happened, but anyway, that's
with an
Hollywood.
with an ice core scientist jumping crevasses for their samples, of course.
As you do, OH&S in action. So, so the next question is, when the permafrost melts, presumably in the tundra, etc., it releases greenhouse gases and other nasties like methane, etc. So, is there anything hiding in the ice if Antarctica melts?
Do you want me to say something here? So the permafrost melting, we're normally talking about the Arctic there, and we are seeing the Arctic warming up. In fact, this last summer was an incredibly warm summer over much of the Arctic, and as the question suggests, there are vast stores of frozen methane, both in the land, in the permafrost, but also in Arctic lakes and at the bottom of the Arctic ocean. And so there is a real concern that as the Arctic warms up, then that methane could be released into the atmosphere. And the critical thing there is that methane is a much more powerful greenhouse gas than carbon dioxide. And so if that happened, or if that started to be instigated, it could act as a rapid acceleration of climate change. Neroli in her presentation mentioned the risk of the collapse of the West Antarctic ice sheet as being a potential, what we sometimes call tipping point, and this would also be one of these examples where we could get potentially very irreversible, or at least largely irreversible change occurring. If we look to Antarctica, as we mentioned earlier with regards to the ice cores, the temperature over much of Antarctica is well below freezing, and so the risk, at least in much of Antarctica, of getting a similar kind of melting is much less. So the concern really in terms of the melting permafrost comes from the Arctic rather than the Antarctic.
Thanks, Emily. So another question is, are we starting to see impacts on biodiversity in the oceans around Antarctica due to the warming that's already happened?
Yep, I can take that. It's not my area of expertise, but yes, we are seeing changes in the ecosystems around Antarctica, particularly some of the structure between sort of the krill and the salps, I think they're called. That type of level of change. But we can also see changes where we have areas where we lose sea ice that can affect the ability of penguins to have successful colonies, to be able to move from their colonies back to the ocean to be able to forage for food. And so those are some of the changes that we're seeing. One of the areas where we are seeing some of the largest ecological changes are along the Antarctic Peninsula, where we're seeing very rapid warming. And that's an area that also has a lot of people coming to the Antarctic, both as tourists but also as scientists. And so there's a very real risk of pests and weeds being introduced to Antarctica, brought from other places around the world, and making it onto the continent. And because we're seeing the climate there warming, that the climate not being as inhospitable, and so there is a real risk of some of these pests and weeds being able to actually establish in the Antarctic in a warming climate.
Perhaps I can add a few things there. So, I mean, as Neroli has mentioned, changes in the sea ice can affect the marine life. If they're, particularly krill, for example, critical parts of their life cycle are associated with the sea ice as part of their habitats. The other thing that's important to mention is that there's so much of the marine life in Antarctica that's incredibly well adapted to the very cold temperatures. We see a lot of giant species in terms of the marine life, so giant sea spiders that are this sort of size, which are they take that gigantic form because they are adapted to those low temperatures. A lot of species that have very slow metabolisms, again an adaptation to and long lifetimes, again adaptations to the very cold temperatures. And for all those reasons, a lot of the marine life is very susceptible to relatively small increases in temperature. And the third thing that I would highlight is an aspect of climate change that we haven't mentioned. Oceans are acidifying, and they're acidifying at a faster rate than we've seen in perhaps 250 million years. And so the other aspect related to climate change, which is of great concern, is the impact of ocean acidification on marine life. And there's some evidence in terms of some of the species in Antarctica of already seeing damage to those species as a consequence of ocean acidification.
Any other comments there? Okay, so we've got a change of pace for this next one. So the question is, what do you do for fun over winter at Concordia, and what is your favourite food on the station? So I think this one goes to Rocco and Carlo.
Yeah, good question. Of course, this is a good point for the person that did the winter over during the years here. So I guess that someone that can answer this is the personnel of the winter over, like Alberto, in example.
It's not easy to go outside for work and also for a fun moment. We go outside every day, and the technical equipment help to do this. But we have the time to walk, to run sometime. Also, it's not easy. And inside we have a little gym. We have some like ping pong, some table, the baby foot table, and the most important moment are when we are in a social moment, like after dinner or after lunch, and in this case we can share our experience and also to show some movies, for example, and this is the most important moment to make a good team, and also when we do a little party, not only when we have a birthday, also when we want to celebrate some special moment. For example, midwinter is the half of the season of the winter, and then we do something special, and this make more strong the team, and especially when we have the very long time of isolation, like 9 months, and 3 months of completely dark. I don't like cheese, but in a Italo-French station this is not so nice, but my favorite food is fish here, and we have, of course, not fresh food, because this is available only during the summer campaign, that's now in this period, but also in the winter we have food of every kind, and it arrives here in Concordia by the Traverse, a ride that starts from the coast, and we store in some containers in front of the station, and it's nice to prepare also the food, because it's a nice moment, and we have a French cook, but on the Sunday, for example, we do shift to prepare ourselves the food for the other members of the crew. Then it's good.
Thanks, Alberto.
Okay. Thank you, Rocco and crew. I have to say you look very comfortable in there, and not at all like what it's outside for you. So just keeping an eye on the time, just perhaps one more question here. We'll just finish off with one which is about policy. So the question is the Antarctic Treaty System robust enough to ensure that Antarctica remains a scientific and environmental reserve for the global good?
I don't know that there's a set answer, a correct answer for that one. I think that we've seen how important the Antarctic Treaty has been for protecting Antarctica and ensuring that it's an area that is used for science and is used in cooperation. I think that if we look to the future, there are no guarantees that that will always be the case, but I think that it's something that we should value, and I hope that the countries around the world will actually make sure that we do continue to have an Antarctic treaty system for many, many decades into the future.
Emily or Carla?
Yeah, maybe I'll just add, I mean, you know, I think we've heard throughout all the presentations today how unique and incredible Antarctica is, but also how important it is for the world. We've been hearing time and time again how Antarctica is absolutely critical to determining our future climate, but also how much a unique wildlife finds its home in Antarctica. So there are many reasons why we might, as a global society, want to continue to protect Antarctica into the future. And we've also heard how important scientific collaboration between countries is. and how that has much greater impacts than just for research. It's also critically important for shaping international policy into the future. So for all those reasons, the Antarctic Treaty System, preserving Antarctica for peace and for science, is incredibly important, and I think we would all hope that it is preserved into the future.
Carlo? Yeah, I follow up with what Emily and Natalie said. I mean, it's really a place of peace and science where you can really work together. Look at the Concordia station. I think that we have a clear example of how international collaboration is run by Italy and France, but there are many other scientists coming from all over the world working in the field with full cooperation, literally sharing the day life, sharing facilities, sharing results, and it's a great example on how life should be all over the world. Antarctica is literally a place of peace and science.
Thanks, Carlo. And Rocco?
Yeah, I just want to add that from our point of view, for the point of view of the person that come here in Antarctica to do science, to do activities here, that is not easy, but not only because the environment, of course, but also because to come here it's also a sort of sacrifice for our life to make efforts to come here and to do science. Also for people that do the winter over here, and this because not only it's a special place where to do science here in Antarctica, but also because this is a good example where something is possible only here in Antarctica, like cooperation for countries that in the other side of the world are not able to cooperate. So this is very important. And this is very important mainly for the Antarctic Treaty. So our wish, it's that the Antarctic Treaty will last and as long as possible. Also for this reason, also because the cooperation, and we are a good example, as Carlos said, we are a good example of this cooperation, but we really need, and I can't tell you that this cooperation here in Antarctica is the key point to do the science here, and we have to make more effort on this, and we have to. We hope that we, as a community, we can last as long as possible.
Thank you very much, Rocco. So it just falls to me just to close off proceedings this evening. Firstly, I'd really like to thank, Anne-Marie?
So, on behalf of my colleague from the Antarctic, on behalf of my colleague from the Programma Nazionale di Ricerca in Antartide, I have two small presents to present you. And yeah. This is authentic. It has been 4 times in Antarctica.
Thank you very much, Anna-Maria, and thank you to the Italian Embassy for those gifts. So I'd like to thank our guests here, that's Rocco and his team, Carlo, Emily and Neroli, for a great sort of multidisciplinary, multi-continent and multi-country presentation this evening. Thank you. Lastly, I'd like to thank the audience, particularly our young audience who have turned up tonight. It's really good to see young people interested in science, interested in the Antarctic, interested in these issues like climate change, which are just going to be so important over the next decades. And lastly, just to say thank you very much to the French Embassy, the Italian Embassy, and also the British High Commission for co-hosting this with ANU. And finally, that there's refreshments outside, hosted courtesy of the Italian Embassy and the French Embassy. Thank you very much and have a great night.
More